everybody. Welcome. So the session today is going to be quite a chill, laid back one. We're going to just do a very easy intro. And then if we have some time, maybe we'll also talk about GitHub. But yeah, just to intro you to myself, I'm Jo Franchetti. As Patty mentioned, I'm a developer advocate at Spotify. So what that involves is a lot of teaching. I write a lot of demos, teaching people how to, code for the web. I write blog posts. I give a lot of talks. I do a lot of mentoring and just generally try and help people understand the web and web APIs better. I have 10 years of experience in working with the web, mostly as a front-end developer. And the things that we're going to cover throughout this course are all front-end developer focused, web developer focused. Yeah, and I am self-taught. So I didn't study web development at university or even computer programming at university. I studied electronic engineering. And then when I graduated, I didn't really enjoy it, and I thought to myself, what am I going to do next? And so I taught myself HTML and CSS and JavaScript, and I made some truly terrible websites for my friends and family and anybody who needed one, and I started to apply for jobs from there. And so I completely understand where you are all now at the start of your learning journey. Like, I've been there, and I know that it's tough, and I want to try and make it as easy for you as I possibly can. So don't be afraid to ask questions as we go along. There's no such thing as a stupid question. If I haven't explained something well, that's on me, that's not on you. So please do ask me to clarify if there's anything that you're confused about. Yeah, so let's dive into it, I guess. Let's talk about an introduction to programming and tools. And I'm sure this is going to be very basic for a lot of you, but what I like to do is I like to start at the very beginning. I try to say that I assume zero knowledge and infinite intelligence. So if this is something that you know already, that's great. But I like to make sure that we've got everybody on the same page. So these first few sessions may be a bit basic for you, but I want to make sure that we're keeping everybody in line. So there are lots of names for programming, lots of different definitions of what programming is. But if we put it simply, programming is just a set of instructions that we're giving to a computer to execute. And if you've ever cooked using a recipe before, you can think of yourself as the computer and the recipe's author as the programmer. The recipe author provides you with a set of instructions which you are going to read and then follow. So it's your way of communicating with your computer when you're writing a program. And it's also your way of communicating with your team as to how you think a problem needs to be solved. And in order to communicate with the computer, we need to speak a language that the computer understands. And that's what we're doing when we're writing code. And computers interpret instructions in a very literal manner. So we have to be very specific about how we program them. So imagine if I was asking you to give someone instructions on how to walk. What are the sort of things that might come into your head if you were trying to write down the instructions on how to walk? The first thing you might say is, put one foot in front of the other. But does this person even know what a foot is or what in front of is as opposed to behind? When we talk about writing programs and coding, we need to make certain that we are being as literal as we possibly can, that we're making sure that things like punctuation and spelling are correct, because the computer is going to interpret exactly what we say. So if we're talking about programming or coding or developing, what you're really doing is writing human readable text for a computer to interpret. And this is the first ever computer programmer. This is Ada Lovelace. And she was the daughter of Lord Byron, and she was born in 1815. So programming was invented all the way back then. And her family was pretty wealthy, and they were able to give her an amazing education in maths and science, which was very unusual for women in the 19th century. And at 17 years old, she met Charles Babbage, who was a very renowned mathematician and inventor at the time. And he'd invented a machine called the difference engine that could perform simple calculations. It could do maths. And he also made designs for a more complicated machine, which was called the analytical engine. And Ada Lovelace was completely fascinated with the idea of the analytical engine, and she wrote papers on the workings of it and how it might be possible for the machine to work with more than just numbers, how it could be given sets of repeated tasks and repeated instructions to complete more complex calculations. And all of her work was theoretical because the logical engine, sorry, the analytical engine hadn't actually been built at the time. It was all just theory. All of her work was just papers. And although we could very easily build it and put it together and prove it now, most of her work went unnoticed at the time because people weren't interested in a theoretical thing that you could do with a theoretical machine that didn't exist. But we now recognize her as the world's first ever computer programmer. So, for any of the women that we've got attending here, if anybody ever tries to tell you that you don't belong in the tech industry, just let them know that it was a woman who invented this whole thing. It was a woman who invented computer programming. So, as I mentioned earlier, programming is writing code for computers to understand. But if you were to tear your computer down to its most basic parts, the things that it understands is electric current, and electric current being there or not being there. So being turned on or being turned off. And when we talk about it being turned on or turned off, we tend to refer to it as ones and zeros. So one would be on and zero would be off. And this is what makes up something called binary code. It's lots and lots of ones and zeros. And this is the native language that computers understand. Strings and strings of ones and zeros. But obviously, that's not very clear for humans to read or for humans to write. So we need to put a translation step in between what we want to say as humans and what it is that the computer understands. And this is called compiling or interpreting. And I'm not going to go into that too deeply here, but these are the steps that are taken that take the code that you're writing and turn it into machine code, which the computer is going to understand and eventually is going to become those ones and zeros. And of course, it is possible as a human to write code which is close to binary code or even binary code itself. And this is called machine code, or you might hear it called assembly code. And you will write it for a very specific processor or a very specific piece of hardware. And we call these machine code uh, languages, we call them low-level languages. And low-level languages directly represent what we call the machine code of a particular processor. So the processor is, you will sometimes hear it called the brain of the computer. It's the thing that does the computation. And so what we're doing when we're writing machine code is we write an operation, and an operation is sometimes reduced to opcode in an assembly language that represents an operation that we want the processor to do, that it is specifically built to perform. So this is an example here, this code that you can see on the screen now, of a low-level language called ARM, and that's an assembly code. And as you can see, low-level languages, they're not particularly easy for a human to read. I mean, if I look at that code, I have no idea what that is doing. But the amazing thing about assembly code is it's very quick to execute because you're literally writing out the operation that the processor needs to do. And that obviously requires a lot less memory to run. But the majority of developers are not going to be writing programs like this. We're going to be writing high-level languages, which is what we are going to be learning in this series. So languages like JavaScript, which is what we're going to be covering, Go, C++, these are much easier for humans to read. They're much easier for humans to write, much easier for humans to debug. And debugging is when you find a problem and fix it. But a higher level language like JavaScript or Go or C++ requires a lot more steps in order to translate it from the language that is being written into the machine language. And we use something called a compiler to do this. And the compiler is a specific kind of program that reads the source code, which is the code that we're writing, the high-level code, and then translates it down into the machine code that runs on a specific processor. So what it's doing is basically a translation step. So it's translating the code that we're writing into low-level operations. And this can often be a multi-step process. So it takes more computing power and more time to run. So if we take a look at those two code samples side by side, they both actually do exactly the same thing. So what they're both doing is they're printing the numbers of the Fibonacci sequence up to 10. And if you have a look at the one on the left, it's just more legible. You know, there's words, there's numbers, there's things that we can recognize in there. And people rarely write in these low-level machine languages, and they often, if they are writing in them, they're for a specific processor. They wouldn't be for everybody's computer. Usually when we're writing these low-level codes, we're writing them for, you know, a very small chip that is running on a particular piece of machinery somewhere. The lowest level language that you're likely to see out in the wild is C, which is a portable language, which means that it's compiled for almost any processor that exists. And you might see it used to write things for, you know, like computer arms, bits of machinery in factories, that kind of thing. It'll run on smaller things like Arduino. So if you want to build an internet connected toaster, for example, you might run C on that. But in this course, we're only going to look at the high-level languages. We're going to specifically be looking at JavaScript to build functionality into our websites, along with HTML, which is what we're going to write the content in, and CSS, which is what we're going to style it with. And over the next few weeks, we're going to look at the elements of a program. We're going to write some ourselves, of course. And today, we're going to have a look at the tools that we're going to need in order to do this. And of course, the tools that you use are going to be a highly personal choice. So I'm just going to cover the basics and give you the recommendations for what I use. But of course, you can use your own. If you have a preference for any of these tools, that's fine as well. And the sort of collection of what we call the tools that we use and the computer that we're using, we call it our development environment. And the first tool that we're going to talk about in our development environment is our editor. And the editor is literally the program that you run that gives you a place to type your code and to save it. And they can offer a range of different functionalities. Modern editors have a whole load of suites of features and extensions to make coding very interesting. And make it a pleasant experience, I guess. Some of the fundamentals that you'll be looking for in an editor, the first one is syntax highlighting, which is when it adds colors to your text to make it easier to read and sort through quickly. The best editors allow you to customize these colors as well, so you can pick a theme. You know, if you prefer to have your computer in dark mode, you'll be able to set it to dark mode. I use a theme called Fairy Floss in my editor, which makes it all pink and purple, which makes me very happy. And editors, as I mentioned, also offer extensions and integrations to make them easier to use. So you might need, for example, a spell check. You might need linting, which makes sure that your code is matching a certain standard. And we'll talk about linting a bit more later. Remote sharing tools come with a lot of editors these days, which allows you to share your code with people on other computers so they can take a look at your code and, see if they find a bug anywhere. There are a bunch of shortcuts to make editing easier. So there's one that I have set up which duplicates a line, which I really love. And they often come with a bunch of code snippets. So you will find yourself, especially when you're writing HTML and CSS, typing the same thing quite often. And code snippets and boilerplate just save you time. And of course, most importantly, as Jonathan has just noticed, is pets. So VS Code Pets lets a little dog or a cat or Clippy, the Microsoft paperclip, run around in your window, and it's just cute. It's fun. Another thing that your editor will let you do is debugging. So your debugger, what it'll let you do is it'll step through every single line of your code, and it'll tell you the output of it and how the value of any variables that you've written are going to change. And it'll help you find out exactly where in your code it's doing something unexpected. And these are the three most popular editors of current times, I guess. The one that I use is VS Code, and that's the one that I'm going to recommend that all of you use. It's a Microsoft tool. It is free. It runs on Windows, on Mac, on Linux, and it's got all of those features that I just mentioned. So it does syntax highlighting. It's got a debugger built in. It allows for remote sharing of code. So as we go through this workshop, it might be helpful for me to be able to see the code that you're running. And that's really helpful. So if you don't have any other reason for not using VS Code, I highly recommend getting VS Code installed now if you don't have it installed already. If you Google for VS Code, you should be able to get it installed. Anybody who's struggling with getting it installed, just give a shout in the chat and I'll give you help at the end. So this is a front-end development course. So we're going to be building websites, which are usually viewed in a browser. And the browser is your window to the entire internet. It's what retrieves information from the web and displays it on your desktop or your mobile or your watch or sometimes even your fridge. And information is transferred to your browser via the Hypertext Transfer Protocol, or HTTP. And this defines how the text, the images, the audio, and the video are transmitted on the web. I've just seen there's a question come in the chat. Can you please explain the steps that are involved in compilation briefly for JS or Python? Linting spell checks are one of the steps, if I am not wrong. I'm going to leave that for a later lesson, if you don't mind, just so that we'll have a bit more context for what it is that we're looking at. But when we get onto JavaScript, I will definitely talk about what is happening, what the browser is actually doing, and what we're checking for. Sadly, and I'm sure you've noticed this around the web a lot yourselves, browsers interpret data and they interpret your code in different ways. Different browsers will display a website differently. And this can lead to websites looking or functioning differently across different browsers. And when we talk about web development, something we often talk about is creating consistency across the web and creating consistency across browsers. And there's a whole standards body that exists for making sure that HTML and that CSS and that JavaScript are all standardized, and that they have descriptions for how they should act and how the browser should act as well. And we're going to find this a lot as we start building websites, that we will need to test our website in multiple different browsers to check its functionality. And so when I say multiple different browsers, what am I talking about? Well, the most popular browsers on the desktop are Edge, Chrome, and Firefox. So Edge is the newest offering from Microsoft, Chrome is by Google, and Firefox is by Mozilla. And then on your mobile, the most popular browsers we've got are Safari, Chrome, and Samsung Internet. Safari comes with your iPhone, Chrome comes with the Android, and Samsung Internet comes with the Samsung phones. And there are, of course, many, many other browsers than this that I've not included here, because when we're designing, most of the time, we want to be designing for the majority of the population. And so we don't need to consider those much smaller usage browsers at first. And of course, browser choice is as personal as editor choice, and browsers are just as customizable as editors these days, and they come with extensions and they come with debugging tools. And one of the most important choices for me in the browser that I choose is the debugging tools, the developer tools that come with it. And you are going to become intimately familiar with these developer tools over your web careers. I'm not going to cover Python at all in this session, but I can certainly give you some Python resources, but we won't be covering Python at all during this session, I'm afraid, or during my sessions. Someone has mentioned other browsers like Brave and Edge are based on Chromium. Exactly. Will the session be recorded? Yes, it is being recorded. I think it will be published on YouTube. Yes, I'm sure Patty can help us with that at the end. There we go. Excellent. Cool. So as I mentioned, our browsers come with developer tools, and the developer tools allow you to see the code behind the website that you're looking at, amongst other things. So if you, in your browser right now, right-click and choose Inspect, I wonder if this will show up in my shared screen. It does not. That's a shame. Can you see that? No, you can't. Okay, well, if you right-click anywhere in your screen and choose the Inspect option, you will see your developer tools. The slide resources will also be shared too. And the developer tools will show you the HTML that makes up the page. And they will also allow you to view the JavaScript on the page and the CSS on the page, along with a whole load of other tools. So we can have a look at how long it takes to download the resources of the page. We can clear the memory, so we can clear the cache. We can have a look at the console. There's a whole load of really interesting tools in here, which we will look at as we go through this session. So I mentioned briefly there that we have something called a console. You might hear it referred to as a CLI, a command line interface. And we have one that runs on our computer as well, which on a Mac is called the terminal, and on Windows is called the command prompt. And this is where you're going to type in commands for your machine to run. And we're going to use that occasionally during these lessons to use Git and to start up new projects, that kind of thing. And some developers actually like to program directly in the command line instead of using an editor because they find it faster. But I personally like the visual tooling of an editor, so that's what we're going to use. But like I say, it is personal choice. For the purpose of this course, we're going to be using the terminal that comes with VS Code. But you can, of course, use your Mac terminal, or you can use Bash on Windows, or you can use Windows PowerShell, or a whole host of other different options. But I'll be showing you how to use the command line tools that come with VS Code. One of the things that you're going to find yourself needing to do all the time is look stuff up. And one of the best resources that you're going to find to look up information about the things that we're going to be learning is MDN. And MDN is the Mozilla Developer Network. It contains documentation on every single bit of JavaScript, of CSS, of HTML, every single description of how these things should work and what the standards say they should do, along with example code, which is going to show you how to actually use that HTML, CSS, or JavaScript. Then the next resource that you're going to find yourself on a lot is Stack Overflow, which is a forum where you can ask questions and find answers and talk to people who have had the same problems, who are trying to solve the same problems that you are trying to solve. It's incredibly useful if you're stuck on an implementation. There's usually someone who's come before you who's tried to do the same thing and has asked the question. So you will usually find an answer to your question. Stack Overflow does come with the warning that the community can sometimes be a little bit caustic. They can be a little bit unwelcoming to beginners occasionally, but there is a lot of useful resources there. And if you do get engaged with it, you can find some really great, useful answers to questions. There's also a lot of online courses and schools which will take you through beginner-friendly tutorials. I highly recommend, if you're taking this course, that you also read through some other courses and really augment your knowledge as much as you can. And there are lots of other places to find code that others have written if you just want to see what they've made or find some nice inspiration. So these are some that I really enjoy when I'm, looking for inspiration, or I just want to see some nice code that someone has written and try and understand what they've done. So CSS Tricks is absolutely brilliant if you're struggling to learn CSS. Chris Coyer, who writes it, has written some just truly excellent explanations. It's not only CSS, there's JavaScript stuff in there, there's HTML stuff in there. And he writes a bunch of really interesting demos and then explains how to build them so you can sort of follow along. I highly recommend CSS Tricks. Especially their article on the shapes of CSS. When I first read this, it kind of blew my mind. Like, you can draw with CSS. And this one on Flexbox, we'll talk about Flexbox a lot later on. Smashing Magazine is an excellent place for creative web development articles. So if you're starting to interview for developer jobs, it's really good to be reading Smashing Magazine. It gives you something interesting to talk about in an interview and will teach you a whole load of new things. And then Code Drops is one that I really love. It's where web developers and web designers put their most recent snippets of code for all kinds of beautiful things. So you'll find beautiful buttons on there, beautiful drop downs, carousels, you name it. There's a whole load of beautiful web design on there. Something that I find myself using often is tools for generating code. So I mentioned that our editors come with code snippets for us to use. There are also a bunch of websites that will generate code snippets for you. So if you want a gradient in the background of your website, there's a gradient generator. If you want to make CSS triangles, which you will end up doing more often than you expect. For example, if you want to make a little arrow shape on your website, or if you want to put a triangle on the bottom of a speech bubble, for example, the CSS triangle generator is very useful. The accessible color contrast checker is actually built into Chrome now. The code snippet tools that were mentioned are the ones that come with your editor. So VS Code will allow you to, for example, type in a shortcut and it'll fill out the basics for an HTML page for you. The accessible color contrast checker comes for free in Chrome now, but there is also an external one. If you're not using Chrome, what this does is it makes sure that the color contrast that you've chosen for your design is accessible for folks who are colorblind or who are visually impaired. And then another tool that you might end up using often is a code sandbox. Yes, the slides will be shared. I'll put the link in the chat at the end, and I'll make sure that Patty shares them out on the socials as well. So code sandboxes are where you can share snippets of your code or sometimes entire projects if you want other people to be able to look at them, or if you want to look at bits of other people's code. And it's great. It runs the code in the browser and you don't have to set up a file server on your own computer. You don't have to set up a server somewhere in the cloud. It will just run it. So these are my favorite ones: CodePen, Glitch, JSBin, and JSFiddle. Let's take a brief look at CodePen first of all. So this is CodePen, and you can see, so I have a bunch of pens here, but let's go to the trending tab and have a look at what people have built on CodePen. So here we go. Somebody's built this beautiful thing here, and I can see all the HTML that they've got. I can see the CSS that they've got, and I can see the JavaScript that is running here. And so if you're, for example, building a part of a website and you're stuck with something, or you want design inspiration, CodePen is absolutely brilliant for sharing your code with other developers and for just taking a look at what other people are building. Let's see if there's any other nice examples out here. Oh, parallax scroll animation. Go on. Oh, that's rather beautiful. So the people who share this are sharing it because they want to show what they've done and they want to inspire other people. And quite often they are more than happy for you to take their code and use it in your own websites. So CodePen is an absolutely excellent learning resource for you. And then the other one that I mentioned is Glitch. And Glitch allows you to build an entire website in the browser. So it's an editor that is based in the browser that also includes hosting. So if we make a new Hello World app. Oh, I'm not sharing the tab. Sorry, I'm going on and you're not even seeing what I'm looking at. Let's go back to the start. So this is Glitch. And I just clicked on basic starter here. So what it's doing is it's creating a project for me. And then we can have a look here. So we can see the HTML, the JavaScript. We've got some CSS in there as well. And it will eventually render in this pane here. Sadly, glitch is not as fast as it used to be. And what it's done is it's also, there we go. So this is the website that you can see that they've created for me, and I can go in and edit it. So if I jump into the HTML here, I can change this to say, hello world. And let's change my H1 to say hello world. You can see it's changing live. And what it's done also is created a URL for me. So if I now visit this URL, are you going to let me copy that? There we go. If I visit this URL in a new tab, it is also hosting that entire URL at that entire website at that URL for me. So this is another brilliant way if you're working with a mentor or if you're working with a team and you want to share them something that you've done quickly without having to set up a server or go through GitHub or anything like that. This is a brilliant tool for that. So let's jump back into sharing my slides. You are jumping ahead, but we will talk about the difference between HTML and JavaScript and CSS in a little bit. So before we do, I just want to say, like, this might feel like a bit of a whirlwind and it might feel like a lot of information all dumped on you at once. And don't worry if it doesn't feel like it's sticking. Don't worry if it doesn't feel like all of this has been useful to you yet. You can keep these slides and refer back to them in the future. If you ever find yourself stuck or looking for resources, these are things that are eventually going to become second nature to you, but it will feel clunky and a bit weird initially. And before we move on to doing some actual practical work, I just wanted to share with you this quote from Tim Berners-Lee. And this is the man that invented the World Wide Web. And when he did so, he made it for everyone. And he genuinely said, this is for everyone. And that was his wish for the web. And the web's greatest strength over the last 30 years is that anyone is able to build anything on top of it. We don't need to pay money to do so. We don't need to pay like a license fee or anything like that. Anyone can pick up HTML, CSS, and JavaScript, host something on the web, and other people will be able to see it. And over the next few weeks, we're going to be picking up HTML and CSS and JavaScript. And I hope that I can share with you the joy of the web that is that we can just build things with a text editor and with our brains. And like Tim said, the web is for everybody, and we have the power to make it what we want it to be and to build brilliant, wonderful, accessible websites for everyone. And the thing that I always like to say is that I like to try and leave the web slightly better than when I found it. My cat is trying to get involved again. So how much time have we got? Oh, we've got ages. So let's maybe take a look at our next session. So the next thing that we're going to talk about is version control. This is Puff. I've been away for a week and Puff is very clingy and she's very annoyed that I went away. So she likes to come and double check that I'm not going away again. So let's move on and talk about version control. And I'm going to swap over my slide deck just briefly. Awesome. Okay. So we are going to, in this course, use a particular type of version control, which is called GIT. And we use that to track the changes that we make in our code as we're writing it. It also allows us to keep a backup of our code so that we don't lose all the work that we've been doing. And it allows us to make it possible for other people to work on our code with us at the same time. So before we get started, let's just have a brief history of what came before, because Git is pretty much the standard way that developers share their code these days. It's been around since 2005, but on the grand scheme of things, we say the web is 30 and a bit years old. So 2005 is relatively new. So what did developers use before, and why was Git invented in the first place? So let's paint a picture. You're a developer and you are working on a project and you're writing some code, which is, if we break it down to its most basic, is just a bunch of files with some text in it. So you're writing text into a file. You take your files and you want to put them on a server, which is going to serve them to the rest of the internet. So you take your files and you put them on the central server. And you're going to use something called FTP to do this. And this stands for the File Transfer Protocol. And a protocol is just a set of rules that describe how machines are going to communicate. So we've got your laptop and this server somewhere out on the internet. And we need your laptop to communicate with that server, take the file from your laptop, put it onto the server. But you may also have colleagues who want to work on that file. So now you're creating a file, you're saving it on the server, and your colleague is getting it from the server, changing it, and re-uploading it, which is great. You know, we've got a way that both of you can work on a file. But what happens when both of you make changes at the same time? Now potentially there's two copies of the same file, or maybe your copy accidentally overwrites a change that your colleague made. You could accidentally end up deleting somebody else's work. And what happens if you made a mistake and you want to undo it? You have to undo those changes locally, but there's no way to know whether your colleague has made changes that you might be undoing, because there's no history of what the file has looked like. Not only that, every time you make a change, wouldn't it be nice if you could put in a little note that said, like, the reason why I did this was because, you know, we needed this extra functionality, or I was fixing this thing that was wrong, or I was doing this because a particular customer asked for it. You know, did it fix a problem? Was it a spelling mistake? Why was it that you were making this change? And so version control allows us to do all of these things. We needed a way to track changes and manage the changes to make sure that nobody's work was lost. And version control was invented to do this. And version control systems record changes to a file over time so that you can look back at the file and see the history of how the file has changed. And version control is distributed, which means that lots of different people can use them at the same time from anywhere else in the world. A whole bunch of developers can all work anywhere, anytime, and collaborate asynchronously. So one person does a bit of work, they push it, the next person pulls that work down, does some work, pushes it. And not only that, we can add notes, which we call messages, which are going to explain what we were doing when we made the changes. So these are not only useful to our colleagues who were trying to explain, you know, why did we make that change, but they're also useful to us in the future because the number of times I've made a change, I've gone on holiday, I've come back a week later and then gone, what was I thinking? Uh, it really helps you remember where it is that you left off. And version control also lets you manage conflicts between changes that you've made and changes that a colleague has made. So if you're both working on a file at the same time, it is absolutely no problem. It's going to be able to tell you who made what change and in what order and how it is that you want to merge those changes together to end up with the most correct up-to-date file. And originally, there were a few different version control systems created by various different developers who wanted to, fix this problem. But the one that became the most prevalent, the one that most developers use today, is Git, which is what we are going to be learning. And there's a whole terminology that comes with Git. First of all, why is it called Git? There's a few different reasons behind this. The inventor of Git, the guy who created it, is a man called Linus Torvald, who's also the guy that created the Linux kernel. And he claims that he called it Git because it was a random 3-letter combination that was easy to pronounce and wasn't used by any other computer programs or computer commands. But he is also quite egotistical and not the most pleasant human. And a lot of people say he was self-aware enough to name it after himself. And if you're not based in the UK, a Git is kind of an unpleasant person. So who knows why it's named that? So what we're going to do now is we're going to do a quick introduction to some of the language of Git. Don't stress too much if it doesn't click immediately or if you don't remember it immediately. We are, of course, going to go over this as we go through the course. And with repetition, this stuff will just stick in your head and it will become second nature. When I was in my first job, it took me ages to get this committed to memory. And what I did was I actually printed out a cheat sheet and I sellotaped it to my desk so that I would have all the Git commands that I needed. Like I say, this stuff will eventually become second nature to you. Do not stress too much if it doesn't click immediately. So the first thing that we've got is a repository, or you might hear it called a repo. And this is the place where you are storing all of your files. So we're going to be writing HTML and CSS and JavaScript files. We're going to be putting them into folders, and those folders might also contain some images. So this collection of files and folders, this is our repository. And it also includes our Git information, which includes the history of the files. So we can look back and see all the changes that we made. We have two versions of the repository. We have the local version, which is the one that runs on your computer, and we have the remote version, which is the version that you are going to push to the cloud somewhere. So that's going to be saved on a server somewhere out in the internet that you and the rest of your team will be able to add to and to work on. So we have local on our laptop and remote, which is the one out there in the wild somewhere. When you are creating a new repository, a new repo, you will initialize it. So what that does is it adds all of the information that Git needs in order to start tracking the history of your app. You're going to do this only once, your Git initialization, and then you will work on the project until it's finished. And then when you start a new project, you will need to do a Git initialization on that new project. When you are working on somebody else's repository, so a remote repository, you will clone it. And what that does is that takes a copy of the remote repository, so the thing that's out there on the cloud somewhere, and it will clone it to local. So you're taking it from the server and you're making a copy of it on your laptop or your computer. When you then make a change to that repository, you will add it. So let's say, for example, like when I changed the text of that heading, that was me making a change to the HTML. So I will add that change to our history by running git add. And what that's going to do is that's going to say a change was made. It's now ready to go and be added into the history. When I want to actually send that change, I am going to commit it. So that's going to take any of the changes that I've made, make a new revision in the history, and we'll say this is where you can add a message. So for example, I change the heading. So I might say updating heading because of new copy that came down from marketing or something like that, just so that people know what changes I made, or found a bug, updated this to fix it, or changed logo from blue to green because designer said so. Something like that. A message that allows people to understand why it is that you made that change. When you have made your change, in fact, I'm going to explain pushing first. When you have committed your change, you are then going to push that change. So at the moment that you commit, your change is still local. The remote repository doesn't know anything about it. So we need to push that change to the remote repository. So first we add the change, then we commit the change, and then we push the change, and the change will be pushed to the remote repository. If one of our colleagues has made a change, then we can pull it. And pulling will update our local copy of the code to match the remote repository. And it's time to actually do some practical work. Woohoo! So we are going to all make an account with GitHub. If you don't have one already. If you do, please log in. If you don't, we're going to go to github.com. Thank you, Patty. Let me share. So this is GitHub. If I log out. So this is what you will land on if you go to github.com. And what we're going to do is you're either going to sign in or sign up. So if you don't have an account, click on sign up and you're going to create a new account. So enter in your email, create a password, all of that fun stuff. If you do already have an account, then you want to sign in. If you could all give me a thumbs up in the chat once you have your GitHub account set up, I will let everybody just have a couple of minutes to get that done. If you are struggling or if you need some help, give a shout in the chat as well. And we can help. Yep, I was on mute. Wow, brilliant. Thank you, everybody. Sorry about that. Okay, so what I was saying was we're going to create a new repository. And so we're going to click on this green button here. You puff. We're going to click on this green button here, and we're going to create a brand new repository. And what I was just saying before that was don't worry too much if you don't have all of the noise that I have going on that page. It's because I have 10 years of GitHub repositories going on. So we're going to create a new repository, and we are going to give it a name. So the owner is going to be me, and the repository name, let's call it GDG Workshop. And you can call it whatever you like. The thing that we're going to start next is a basic HTML page. So if you want to give it a description, what we're actually going to end up building is a portfolio. And then you can decide whether you want to set it up to be public or private. I'm going to set it up to be public so that everyone can see it. And I'm not going to set it up with a README file or any other files. I'm just going to click on this green button down here that says Create Repository. So I will give everyone a little while to set up their new repository. Give me a emoji of your choice in the chat if you are set up. Let's get Puff in the shot a bit more. There you go, Puff. She likes to be the star of the show. This is brilliant because she sat exactly where I need to be, moving my mouse. Awesome. We'll give everybody just another minute. I'm very much enjoying everybody's emoji choices, apart from the tooth. I hate that. Now all I'm going to get from now onwards is teeth, isn't it? Teeth, teeth, teeth. Okay. So we have created our new repository, but at the moment it has nothing inside it. So, but it has given us a bunch of instructions for how we can add content to it. And the way that we're going to do that is we are going to actually open up our editor now, and we're going to initialize a new Git repository. So with that said, open up Visual Studio Code or your editor of choice. And let's stop sharing and let's share my VS Code. So I mentioned that I have Fairy Floss installed on my VS Code. So my VS Code is all pink and purple. Of course, there's an update. Everybody give me a thumbs up in the chat if you have VS Code installed. Lovely. Good, good. Awesome, 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 awesome. Okay. We are going to those who use Visual Studio. Yeah, if you're using Visual Studio, you know, you made some life choices and you can live with them. So we are going to create a new file. So you can either click on new file in the start menu here, or up at the top, we can go to file, new file. And I'm just going to create a file which I'm going to call readme.md. So we can just make it a text file, and then we can type in hello world. And we're going to go to file, save as, and I'm going to create a new folder to save this in. So let's create a new folder. And I'm going to call it workshop. And inside my workshop folder, I'm going to save this as readme MD. And MD stands for Markdown. So we're going to be writing what is called a Markdown file, which is just a kind of a nicely styled plain text file. And in Markdown, we have very similar. Writing Markdown is quite similar to writing a Microsoft Word document. You know, we have titles, we have subtitles, we have paragraphs, we can insert images. And if you want to make something into a title, you put a little hash in front of it. So we're going to put a hash and something. This is going to be our title. So welcome to my portfolio. And then this will do for now. And make sure you save those changes. So everybody give me a thumbs up in the chat if you have a README which is saved in a folder somewhere on your computer and you've saved it as readme.md and you've got some text in there. Give me a thumbs down if you're confused or you're stuck or you need some help. Cool. I'm going to give everybody else an extra minute or so. If you are interested in changing the theme of your Visual Studio, by the way, you can install different themes in your extensions. So this little icon here, I've got Fairy Floss. This is the one that I've got installed. There are a whole load of different themes available to you. I believe you can also change the theme in View. Yeah, so you can there's definitely somewhere in here where you can change the theme. Where is it? Oh, anyway, settings, themes, colors. Ah, thank you. Oh, is that under file? The settings icon in the lower left. Ah, thank you very much. They've moved it. Settings, themes, color theme. Thank you very much. So if you want to change your colors, you can absolutely do so there. Don't we love them? We absolutely love Microsoft. Okay, awesome. So we now have a file on our computer, but it knows nothing about Git and Git knows nothing about it. So we need to make sure that we have Git installed on our computers first. So what we're going to do is we're going to open up our menu again, and we're going to open up the terminal, and we're going to click on New Terminal. And to make sure that we have Git installed, we're going to type in git ---- version. So if you don't have Git installed, what you're going to need to do is install it. And if you don't have it installed, you are likely on a Windows machine. Mac, Git comes with the operating system. If you don't have it installed and you're on a Windows machine, Git for Windows is what you want. Oh, I'm not sharing the right screen again. So if you are on a Windows machine and you don't have Git installed, you want to go to gitforwindows.org and get Git installed. So download. Everybody give me a thumbs up in the chat if you have, the version doesn't matter at all, don't worry. If you have Git installed and you're ready to Git, give me some thumbs. Give me a thumbs down if you're struggling. If you're using Linux, I believe Git also comes for free with Linux without having to do an install. Oof, that light theme VS Code is a lot. Okay, I'm going to give everyone another minute or so just to make sure that we've all got Git. I've noticed we're getting fewer and fewer thumbs. Is that because people are going to follow along later, or are you confused? If you're stuck, or if you're not sure what's happening, please do shout, because you only get all of us here for the next 50 minutes and then you are on your own. So it's much better to ask while you have us here and we can help. If you're going to follow along later, that's absolutely fine as well, though. I don't know if you can hear my other cat crying at the window to be let out. I'm going to go let her out while we give everyone 1 more minute to get Git set up, and then I will be back. Turns out she didn't actually want to go outside. She just wanted dinner. She's going to have to wait. Okay, so Git. I mentioned the thing that we need to do is we need to initialize. So we are going to run in our terminal git init and press enter. And hopefully you will get a message saying that, and of course I am not in the correct folder. Okay. We are going to need to change directory before we run git init. If you have already run git init, don't worry too much about it. I'm not in the correct directory. I'm not in the directory where my README has been saved. So there's a few different ways that you can do this. We can either do it in the terminal or we can do it visually. So I'm going to show you how to do it in the terminal. So what we're going to do is we're going to use a command called cd, and cd just means change directory. So I'm going to cd into my documents and then into my dev folder, which is where I saved it, and then into my workshop folder. If you don't want to do it that way, if you can't remember where it was that you saved the file, don't worry too much. What you can do is you can click on this icon here where it says Explorer, and you can click on Open Folder, and then you're just going to navigate to where you saved that thing. So mine is called Workshop. And then what it'll do is it'll open that in a new Visual Studio window. So you can see we've got the README here, and then we're going to open up the terminal and we will be in the correct folder. So I can now, to double check that I'm in the correct folder, I can type in ls, and what that is going to do is list everything that's inside the folder. And so you can see I am now in the correct place. Now I can type in git init. And now we have an empty Git repository, which has been initialized inside my folder. Give me a thumbs up if you're with me so far, or a thumbs down if that confused you. Sorry, I forgot that we needed to go to the correct folder first. So on a Windows machine, you won't have Git installed by default, so you will have to install Git as well as your IDE. If you're on a someone else has already answered. If you're on a Mac or you're on Linux, Git will come as standard. You're on Linux as well. Okay, cool. So just double check if you're on Linux, double check that you have Git installed by doing git ---- version, but it should just be installed. Jonathan, you're seeing this repository is empty. It may well be because you're not in the correct directory. So just double check that you've got the correct directory open and that you saved your README file in that directory. And yes, this is being recorded, so you will be able to go back over it. And I will also share all of the slides which have all of these commands written out one by one in the slides. So you will also be able to follow through with the slides. Okay, so if you have... Yes, so what I would recommend is creating a folder for this new project, call it workshop or project or whatever you want, and then run git init inside that new folder that you've just created, and that will initialize a new Git repository inside there. So now if I type ls, no, we haven't done that yet. So at the moment, we're still working fully locally. We haven't told our remote Git account about this project at all yet, but we are just about to do that. So I mentioned that when we want to make a change, we want to add it and then commit it and then push it. And before we do an add, there's a command that we can use to double check for any changes, and we can use something called git status. When you type in git status, Git will tell you what changes have happened. So at the moment, all we've done is we have added in a README file. So it said we've got one untracked file here, which is readme.md. And it's telling me now use git add and the file to include it in a commit. So that's exactly what we're going to do. We're going to say git add readme and press enter. And once it has been added, if you type in git status now, you should see that it is green. So it is saying we've not committed anything yet, but we have added a new file. So the fact that it's green means it has been added. So now we are going to commit it. And to commit it, we are going to type git commit. And then we also want to give a message. So this is the message that I was talking about, where we let our colleagues know, or we let our future self know what it was that we were doing when we were doing this. And in order to add a message, we use -m. So that's git space commit space -m. And then our message is going to go inside of some double quotes. So I've got some double quotes there, and I'm just going to say, creating a readme. And I'm going to press enter. So now if we type in git status again, you can see that we are committed. So there's nothing, we've sent that commit. There's nothing to do. What they say, the working tree is clean because we have committed. Now what we need to do is we need to link our remote repository to our local repository, because at the moment we've created that remote repository on GitHub and we've got our local repository on our computer, but they don't know anything else about each other. And Luckily, I'm just going to stop sharing and share my browser again. Git has actually got all the commands ready for us to do exactly this. So we are going to, the thing that we want to do is push an existing repository from the command line. So we've done our add, we have done our commit. Now we want to push. So yes, you will get that. So that isn't an error. What it's asking you to do is to tell it who you are. So do exactly the thing that it's asking you to run. Okay, Git shows all the files from the previous root folder where I did Git in it. So you need to make sure that you are in the correct folder when you are doing this commit. Next session, we are not going to collaborate, but we will all be continuing to push to this project. So what we're going to do is we are going to, first of all, add our remote, which is going to be the URL of the Git repository that we created online. So we're going to copy this line here. And you may well get that that notification that someone else has had here, which says, please tell me who you are. Run git config -- global user.email and put in your email address, and git config -- user.name and put in your name. So what you will want to do is just run that exact command. And then change this to be your actual email and change this to be your actual name. I've already done that, so I don't need to do that, but you may well need to do that. -m is, yes, it's just a message where it's just a place where you can type in a message to tell yourself what it is. Oh, I'm not sharing my screen. Thank you. I'm glad everybody else is more awake than I am today. Yeah, so if it's asking you to tell it who you are, you just want to type in the exact command that it gives you, and then change the bit where it says you@example.com to be your email address and your username. So your actual name will go in there, and then just press enter. Okay, so what we've done here is we've told the computer that the remote that we want to connect it to is that GitHub repository that we set up earlier. Now what we're going to do is we are going to make a new branch, and we're going to call it main. So the way that we do that is git branch -m main, which is going to create a new branch for us. And then once you have got that new branch set up, we are going to push to it. So if we jump back into Visual Studio, where is it? Here. We are going to do git push origin main. And that is going to push our changes to our GitHub repository, to our remote repository. The difference between the -m and the capital M. In GitHub, it mentions push -u. -u, let's have a look. You know what? I don't actually know what the -u is for. Let's look it up. Yeah. -u seems to mean update, maybe? Oh, setting the origin as default. Interesting. But is it not default by default? I'm just trying to find the answer for you right now. No one seems to be explaining what -u is. If anybody is having better Google food than I am, changing default to main instead of best. No, I don't think it's that. Because, I mean, it worked just fine without the U. Ha! Somebody asked ChatGPT. Nice. Set upstream. Ah, okay. Very nice. Well, every day is a school day. Okay, so it allows you to set upstream so that you can then use git push or git pull without having to say origin, which is, I never knew. TIL. Okay, so what we have done now is we have pushed. We would also like to know about capital M. See if ChatGPT has an answer for that. The -m flag is often used with Git to rename a file or directory. So it is not the same as lowercase m. I love this. I'm learning with you. Okay, so what we have done is we have created a remote Git repository. We have created a local Git repository. We have pushed our local to our remote. And now if you have a look at your remote repository in GitHub, you should see your README. So I'm just going to jump back to my GitHub. So you should see here your README that you just pushed should now be in your remote repository as well as your local repository. And this is what we're going to be working from for the next few sessions as we build up our portfolio. Yes, exactly. That's exactly right, Jonathan. So with the U, it means we're saying the origin is the default. So we don't need to say git push origin. It's not the branch name, so it's not main. It's saying that we're setting origin to be the default. So we can just type git push and git pull rather than needing to type git push origin, git pull origin, git pull remote origin. I wouldn't worry too much about remembering it all. I mean, you can tell how much I've used it by the fact that I never used it before and only just learned it now. Awesome. So we have a repository, we have a README, we are yes, Git is much more user-friendly than it used to be. It will, if you make a typo, it does quite often say, did you mean something? Don't worry too much about the -u thing. So it's nothing to do with branches, and it's to do with the so we are setting up a remote. So we have our local, which we'd set up with the git init, and then we were connecting it to a remote, and the remote is called origin. This is just the sort of the default name that Git uses. So when we did git remote add origin, what that's saying is I'm setting up this remote, I'm calling it origin. Then when we do the push, we do git push origin, and we say git push origin master, for example, or git push origin main, which is the name of the branch. And so by using the -u, it means we don't need to use the name origin. We can just say git push main. It saves you typing one word, but I wouldn't worry too much about it. I will almost certainly forget, and I will tell you to use git push origin in future. So we're saying it is default. Oh, you know what? We're not going to use it, so I'm not going to think about it. We're going to be using the longhand in our Git from now onwards, so do not worry too much about it. Can you tell us why we need to do the git branch main? Yes. So one thing we haven't got to yet is talk about branching. So when you're working on your GitHub repository, you might maybe want to make a change without changing the code for everybody else. So you might say, I'm going to work on this one feature. I don't want anybody else to have to deal with the code that I'm working on. So I'm going to work on what we call a branch. And you can think of it exactly like a tree. So you have your main branch, which is where most of the coding is going to be done. And then if you want to make a change, you make a branch and you make your change on that branch. And nobody else is going to see that work until you merge that branch back into main. And so we can make as many branches as we want. And good practice when you're working in a team is to make a branch, to get one of your colleagues to have a look at that branch, and then to merge that branch back in. And this way you're not all working on main, and you're not going to cause yourself merge issues. You're not going to have problems where two of you are trying to edit the same code at the same time. And what we're doing when we say git branch -m main is we're saying create me a new branch called main and put me onto that branch. So I'm on the main branch right now. I'm working on the main branch. What we've done is we've pushed to the main branch. And what we could do in future is we could say, like, I'm going to make a branch which is called, feature one. And on feature one, I'm going to add in a new section to my portfolio where I have an introduction to myself and a photo. And I'm going to make a branch called feature one. I'm going to work on that branch. Once I've finished with it, I'm going to commit it and then merge it into my main branch. Cool. So I do have some slides here about branching. So let's just briefly go through them. So as I mentioned, we've done branching. We can share our branches with other people. So let's say I made that feature one branch and I want Jonathan to have a look at it. I can say, Jonathan, could you check out feature one branch? And Jonathan would be able to check that out and pull that down to his local repository. And then he'd be able to say, like, yes, this is great, or no, this is rubbish, or potentially you should make this change or that change. And that way he can then also make commits on that branch and can work on that branch. And we don't have to worry about it getting merged back into master until we're all happy with it. When you are working on a branch, and I talked about our branching out and then merging back into main, if you make a branch and you make a change, then you want other people to take a look at it and say whether or not they like the change that you made, whether they think that you should make more changes. This is when we do something called a pull request or a merge request. It's called a pull request in Git. It's called a merge request in GitLab. Merge request is actually a better name, in my opinion, because you're asking for it to be merged, but Git is as Git does. But it's a great way to make sure that you and your teammates are all coding to the same standard, that you all understand the changes that are being made. This is where we ask for something called a code review. So, I can say, I've made a change on this branch called feature one. Could you please take a look at this code and make sure the code is up to the standard that you expect for this project? And then if you like it, you can say that it's okay to merge it. So that's what our pull request is for, or our merge request. And it's really good practice to do a code review, and it can feel really personal when somebody reviews your code, and it can feel like, they're making a judgment on how good you are as a developer, but that's absolutely not the case. They people make mistakes all the time. People are going to spot mistakes that you didn't spot, and that's absolutely fine. And that's why we love code reviews, because it's our chance to learn something new. Of course, people are always going to be difficult. So if somebody is rude in a code review, that's on them and not on you. But most of the time, if somebody finds a mistake in your code or they want you to change something, consider it an opportunity to learn a new thing. So once your merge request has been accepted, then the code can actually be merged. And once your branch has been merged with main, you would usually then delete that branch. So it's no longer needed once it's been merged with main. Sometimes, occasionally, you will get conflicts where two people have been working on the same bit of code and Git can't tell which one is newer. And in which case you will get what is called a merge conflict. And what Git will ask you to do is look through each line of code and tell it which one you want to keep and which one you don't. This can be an absolute nightmare. But mostly Git's very good at working it out. And the final thing that we are going to look at today is forking. So if you see somebody's repo on GitHub that you would like to work on, or that you would like to copy and use for yourself, you can fork it. And this is making a copy of somebody else's repository. And so it sets up a remote version of their repository, and then you can clone that locally and work on it yourself as if it was your own repository. So that is a whirlwind introduction to Git. And like I say, don't worry too much if it all feels like a lot and it's not sticking in. We're going to be using these Git commands at the end of every lesson, and in fact, during every lesson, to make sure that our repository is kept up to date, and you will get that practice of the repetition. So don't worry too much. We are going to be using this repository to build our website over the next few lessons. So on Wednesday, we're going to make an HTML file and we're going to write up the content for our website. And yeah, thank you all for joining. Sorry, it was a bit chaotic. It's always going to be a bit chaotic. There's always going to be things that I don't know that I'm learning along with you. That's why I love doing this so much. Do give me a shout now if you're confused about anything, or if there's anything that you are stuck on, because we've got 15 minutes now to get you some help. If not, thank you so much for joining, and I will see you on Wednesday when we start writing some HTML. And I'm looking forward to it. I'm excited to see all the portfolios that you build.
Yeah, thank you, Jo. Can you hear me okay? My computer is acting weirdly.
Oh no, yeah, I can hear
All
you.
right. Yeah, well, thank you so much. This was an amazing first session. And thank you everyone for joining. We will be uploading today's session to the YouTube channel. You will receive an email where you can, you know, put your feedback, tell us your feedback about this session. That is going to help us. And I will let all of your feedback, I will send it over to Jo. So that will help us, and that will help Jo to make it better. And also, if you think that this was a fantastic session, which I think you already think that, because I'm reading some comments on the chat, on the Discord, and here as well. Let us know that as well. And yeah, remember to sign up for the next one, which is going to be at the same time, but on Wednesday.
Let me get the links for both of the slide decks for you as well. So this is slide deck number 1, and this is slide deck number 2.
All right, and I will add the links to the slides to the description on the YouTube video.
Awesome.
All All right.
And yeah, if you can't make it on Wednesday, we will be obviously recording the session, and I will of course also share out the slides. We're going to be working on the next slide deck for 2 sessions, so there will be spoilers, but I will share out the slide deck at the end of Wednesday, and if you want, you can work ahead and do next Monday's class as well. But yeah,
All
thank you so
right.
much, everyone.
Well, thank you, everyone, and see you on Wednesday. Thank you so much, Joe, and enjoy the rest of your day.
My pleasure. Have a good one,
Bye.
everybody.